Hey there, kiddos. Hope you're doing well. I'd like to introduce some rules and formulas today that we'll use in class tomorrow. So, what I'd like for you to do is just get these rules down in your notes, and we'll look at some kind of fun problems tomorrow where we can use these rules. So, we're going to talk about angles that kind of live within circles or somehow related to circles. The first type of angle is what's called a central angle, right? And what a central angle is, it's an angle whose vertex is the center. It's on center, right? So if we were to create such an angle, all we would have to do is create an angle somewhere here. Here's your vertex, right here, the center, and over there, right? So because the location of the vertex is the center of the circle, we call this, therefore, the central angle, right? And so note that a central angle cuts an arc, right? This is the arc here that it cuts. So what I'm going to do is I'm going to kind of highlight that arc that is cut by that central angle, and we're going to make it how about what color? We'll make it red, and we'll make it nice and thick. Okay, so this central angle here, vertex is the center, cuts this particular minor arc, right? So the relationship between the measure of the angle, central angle, if the central angle is x degrees, then it's the same as the measure of the arc that it cuts, right? So let's make that a little smaller here. So if this central angle happens to be 30 degrees, then the measure of the arc that it cuts is also 30 degrees. Okay, they're the same. Okay, so that's the first rule. So if this angle, the central angle, vertex is the center, if this central angle is 30 degrees, then the measure of this arc is 30 degrees. Okay, they're the same. Okay. The second type of angle, well, we'll call it an inscribed angle. There are a couple more cases we can talk about tomorrow, but an inscribed angle, you know, we've been talking about inscribed triangles, inscribed squares within a circle. So an inscribed angle is just an angle that could look like this. So the vertex of the inscribed angle is on the circle, right? So here's the inscribed angle, and this is where the vertex lies. And so what I'm going to do is note that this inscribed angle, whose vertex is on the circle, note that inscribed angle cuts this arc right here. Okay. And so an inscribed angle, the vertex is on the circle, right, on the circumference of the circle. And if that is the case, then the relationship between the angle measure, this inscribed angle, and the measure of the arc that it cuts. Actually, let me first kind of make that arc, the minor arc really. Let's make it, there we go. So you can see how this inscribed angle cuts this particular arc. Then the relationship there is that the inscribed angle, which we can call x, is really half of the measure of the arc that it cuts. So if the angle is x, then the measure of the arc is really twice that, 2x. Okay. So as an example, I could say that, you know, if this angle here were 30 degrees, then the measure of the arc that is cut by that inscribed angle would be, that's right, 60, right? 30, 60. As opposed to the central angle, where you would have 30 and 30 degrees. Okay? But the way we distinguish a type of angle is by the location of the vertex. Central angle is center. Inscribed angle, the vertex is on. Okay. There are two more cases. This I'll call an internal, and it could look like a lot of different things, but internal angle. Usually it's made of a chord, two chords really. And so what we have in this case is, hold on, we have an angle where the vertex is in the circle, but not on the center. So that could look like, you know, we got a chord here, we got a chord there, here a chord, there a chord, everywhere a chord, chord. And note that the vertex of that particular internal angle is in the circle. It's not, however, the center of the circle, in which case it would be a central angle. But the vertex is in the circle, which makes it what we call an inscribed angle, an internal angle, excuse me. So for this case, the vertex is in the circle. And if that is indeed the case, then the measure of that angle is a little trickier to find because you can note how this particular angle, and they're both the same by the vertical angle theorem, so I'll call that x degrees. Right? Again, so it doesn't really matter that x degrees or that x. They're the same. That's x. That's also x by the vertical angle theorem. So you can notice that what happens is we cut two arcs. This one right here and this arc also right here is cut or created by that internal chord angle. So let me see if I can create those two arcs. I'm going to construct that arc. And oops, it did the major arc. Actually, that's not what I want. So I'm going to undo that. I want the minor arc. So let me see if I can try this again. Boom, boom. Construct. Oops, I got to highlight the circle. Construct arc. There we go. There's one. Let's see if I can get that one too. Construct. Highlight the circle. Construct arc. There we go. So you can see how this either of these two vertical angles, which are both the same, created by an internal chord, right? It cuts two arcs, this red one and that red one. And so I'm just going to, for the ease of notation, I'm going to call the measure of that arc A degrees. And let's suppose a measure of this lower second arc, for lack of a better name, we can call it B degrees. B degrees. Right, so what we're able to do here is we're able to find this internal angle, and the rule for this particular internal chord angle is we're going to take the average of the measure of the two intercepted arcs. Right? So the rule for this guy, I'll kind of write it down here, is that that internal angle, I'll call x, is equal to the average of the two minor arcs that that particular angle cuts, right? So it's a plus b, and since we want the average, we're going to divide that by 2, or multiply by 1/2, right? Okay, it might look a little bit better to write it like this. How about that? A plus b, the quantity, I'll put that on top, over 2. Okay, so the relationship between this type of internal angle, the vertex is inside the circle, yet not on the center. That case would be a central angle. But if the vertex is inside the circle, then this particular angle x, which is the same as that x, is equal to the average of the two intercepted arcs. So a plus b divided by 2. So let's say that this arc were 50 degrees, and let's say this arc were 30 degrees. Right, then the measure of this angle, or this angle, would be 50 plus 30 divided by 2, so that would be 40. Okay. The final case is what I would call an external angle. And again, I'm naming them dependent upon the location of the vertex. So an external angle obviously would have the vertex outside the circle. Out. And again, it's the location of the vertex that determines the rule that relates the angle to the arc or arcs. And so for this particular case, let's give you a quick drawsy. And let's say I got here and here. Okay, so here, way out here, we got an angle, and we can find that angle called x. Note that it's outside the circle. It's an external angle. And this also, much like the internal angle, cuts two arcs, so too does this external angle. And so let me put a point here at the intersection, another point there. And note that this angle cuts or creates this particular arc and that particular arc. So I'm going to try to highlight those and so you can see a little better. So I'm going to construct that arc. Oops, did the major arc. I don't know why it keeps doing that. Gotta figure that out. Maybe if I do the circle first. 1, 2. Try it one more time. Construct that arc. Oh, one more time. So the difference, maybe if I go up, who knows? Construct that arc. There we go. Try it over here. I'll construct this arc too as well. And again, I'm just trying to make this pop for you a little bit. Oop. And I'm not having much luck. Sorry. Try it again. Try constructing that arc. There we go. So again, let's suppose that this arc here had a measurement of A degrees, for lack of a better term. And let's say this smaller arc here had a measure of B degrees. So the way in which we can evaluate that angle, that external angle, with the vertex outside of the circle, is that external angle is half of the difference of the two intercepted arcs. So that external angle, which is x, is equal to the difference, the bigger intercepted arc minus the smaller intercepted arc. So in this case that would be A minus B, A minus B, and we're going to divide that by 2. Okay. So, comma, for example, comma, if this arc measure were 60 degrees and this arc measure were 30 degrees, then the external angle with the vertex outside of the circle would be half of 60 minus 30, which is half of 30, which would be 15. Okay? So, to summarize, angles have measures, as do arcs. And for each of these 4 cases, for angles that somehow interact with circles, we can evaluate the relationship between the angle and the arc. The angle and the arc. The angle and the arcs. The angle here and the arcs. So it's a location of the vertex that determines a rule. And in that light, what I want you to do is please have this down in your notes, because we're going to do some fun problems using this tomorrow. Thanks. Have a good night. See you tomorrow.